So what we're going to do is create a new project. And this is going to be a mini-series of 2 or 3 episodes about how to program in Swift. And more specifically, like how do you go from the basics of Swift to the limits of Swift, such that in order to bypass those limits, you have to go to another language like Idris. So I'm going to take Xcode and go like here, new project, and then select macOS as a platform and command line tool. And we're going to say this is Swift intro, and this is the show, and I don't know why they ask to do that all the time. And we're going to put this in, what's in there? Do I not have stream? Yeah, we have stream. Cool, let's put it in here. Let's full screen that. So the goal here is to uncover the basics of the language. So here's our program. It's just a file. I have a button here that says run. I want to run it. This happens, right? You have a console here that shows what happened. And that's it. So as we've seen, I've hooked up my iPad to my laptop so that I can show you here. As we've seen, yeah, this is really meta. I have a PC with a capture card capturing the MacBook, which itself has a cable to the iPad to capture the screen of the iPad. So this window here is captured through 2 layers of capture: the computer's capture and the capture card, and then transmitted through the internet with OBS. So actually 3 levels of capture. But you have, so that's the iPad. We've seen before, like if I go back, like what is syntax and what is stuff. And so I would say the most intuitive thing is numbers. Sorry, the most intuitive thing to start with in a programming language is numbers. And the reason is not because it's inherently intuitive, but it's something that everyone is taught very early. So if we can figure out how to do 1 plus 2 plus 3, that's already something, right? How do you do numbers in Swift? Let's get rid of this first. What happens if I type 3? Type 3, hit build, and nothing happens. All right, let's see if I do 1 plus 2. All right, nothing. Again, nothing happens. 1 plus 2 plus 3. All right. Pro tip: if you keep doing that, nothing will happen. So what we have to do in order to have something happen is use what was there before, and that's print. So print is a function. We're going to see functions very soon. Print is a function that allows you to take some value, whatever it is, and show it. Like show it here. And that's the console. So whenever we want to do something and see it, we have to print it. There are other ways to see it, but that's the one we're going to use. So, all right, so far so good. You can do 1 plus 2, and that's going to be 3. Ta-da! Nothing special, nothing fancy. This is just like your basic math. What if I want to do something more, something different? Like, what if I want to, so let's say I want to say something true like 3 equals 3. That's something that works in math, right? 3 equals 3. Compile and run. Ooh, we got some big red dashes here. So the red dash is here. The big red line says we have a problem here. I can't continue. I can't give you this program because this program is wrong. And it says cannot assign a literal value. So this is because the equal here is an assignment. An assignment means I'm going to give a name to something. And here the assignment goes from right to left. You give to the left part what is on the right side of the equal sign. So here we're giving the value 3 to the name 3. And this is totally invalid. That's absolutely not what we want. This is just a quirk of how math syntax and how programming syntax is different. So if we want to say something true like 3 equals 3, we have to put 2 equals next to each other. And this is a Boolean test. This is a function that takes one or the other and returns true or false depending on if one of them is true or the other is false. So this is a true statement. 3 equals 3. Let's go back to assignments. So assignments are done with the keyword let or the keyword var. So if we do let 3 equals 3, that works, but we can't really test it. So let's put 3 here. And there we go. We've printed out 3 by using the name 3, and using the name 3 has the value 3 because we have assigned it here. If we remove this equal 3 here, I have an error because 3 here is not assigned to anything. And if I put 4, it works just fine. It's a bit unintuitive, I would say. Like, that's a bit foolish. But you can say that 3 has value 4. Nothing prevents you from giving the name 3 to the value 4. Similarly, you can just do John. And now John has the value 4. And that's just fine. Right? Okay. So numbers are the first thing you would think of when does this still work? Yeah. The first thing you would think of when when translating from existing syntax to programming languages. And math is really nice for that. Can you do something complicated like root 9? Is there, like, can you do that? Root 9. You can't. You could, but by default you can't. And we're gonna see later how you can. I'm gonna write a note like actually I'm gonna do here. Let's implement square root later. So you can't do square root, and the reason is this function square root is not implemented in this way. However, you can do sqrt of 9, and that results to 3. Cool, right? So sqrt is for square root. So we can't use a symbol for square root, but we can use the word sqrt. So now that's really useful. We've used 3 things already. We've used assignments, we've used numbers, and we've used functions. Very basic ones, but we have seen them. Now we're getting to somewhere a bit strange here. You see that if I use sqrt, here I have 3.0. If I just put 9 here, I'm just going to remove the parentheses because it's confusing. If I just put 9, I don't have 9.0. How? Why? Like, it sounds stupid, right? But why is it different? Like, what happens if I do 9.0, however, right? Oh, well, 9.0 is 9.0, but 9 is 9. But then, all right, then why is this wrong? Sorry, not why is this wrong, but why does this not give me 9.0, right? So let's do something funny. Let's say 9. Oh, come on. is an integer number. So integers are the computer equivalent to natural number, well, to natural numbers and negative numbers. So let's say 9 is 9, and then let's do the square root of 9. Does this work? This doesn't work. I'm curious now, does this work actually? Does this even work? All right, this doesn't work. However, okay, if I don't put the 0.0, it doesn't work. If I put the 0.0, it does work. And let's look more carefully at the error that the computer tells us we've made. It says argument type int does not conform to expected type floating point. So here's the thing. Types. Swift has, well, every language has types, but Swift checks that the types, like the type of the different values that you're handling, match together. So 9 is, and colon has type int. However, 9.0 has type either float or double, depending on whatever you're working with. So if I do this, does it work? Yeah, that works. And the reason is sqrt, square root, is a function that takes as input a number and returns another number, but not any number. Only numbers that can be, that have decimal places, basically. That's what a float or a double is. The difference is just precision, is the amount of decimal places, but square root only works with doubles to doubles. And what happens when you give it sqrt of 9? Well, it's going to look at 9. It's going to be like, wait, what is 9? And 9 has been defined a bit earlier. Let me move this around. We have 9 equals 9, right? And so it's going to look into 9, go here, it says, okay, 9 is defined here. How is it defined? It's defined by 9. What is 9? Well, 9 is an integer, right? It has no decimal places. So then it says, all right, is GRT. All right, we have sqrt of something, something, something that is int, and that should return double, right? But the problem is, here we have a mismatch. We have an error. We have something that is not intended. We're saying, please take this integer and make it into double, and that is not at all what square root does. What square root does is it takes a number with decimal places and turns it into another numbers with decimal places. So that's wrong. But then why does this work? Right? We tried this, right? If I do that, it does work. What gives? This works. This works. Why not this? Right? It's all defined the same way, isn't it? Aren't they all equivalent? And they're not quite equivalent, because Swift does what is called type inference and type conversion when it's safe. And when it's safe means a lot of hand-wavy things, but basically, whenever the designer of the language decided, oh, it's not a big deal, we're going to allow it. They decided transforming numbers that you type in into other versions of themselves is fine. So here, even though we typed in an integer 9, this is converted into a double. And the reason it's converted into a double is because square root here requires a double. If square root did not require a double, if square root did require, for example, an integer, this would be considered as integer. Same here. This is it's probably actually converted into a float, when I think of it. But that doesn't matter. You'll see later why it doesn't matter if we have time to get to it. We only have 20 more minutes. I decided to stop at 9. So when you type in numbers by hand, Swift will automatically, oh shit, I just noticed you can't see. That's what I was doing. So here you have the mismatch between square root and int. Because 9 is declared as int here and then carried over here. And then you have square root that expects a double given int, which does not match whatever it expects. And here, this works, this doesn't work. And the reason is because we've typed in those numbers, and here we've typed in a name. And so whenever you type a name, you refer to something that might not be a typed in number, or might be something else. And again, this is a specific decision that designer took, and they said, well, whenever it's a name, we're not going to like analyze the code further and see, well, is the name defined with a typed in number? And if so, then let's be aggressive about converting it. No, they just said if it's a name, like it's one level of indirection too much already. Well, not too much, but like one level of indirection means that we can't afford to go through all the levels of indirection that might go through there and convert them as willy-nilly. So because, for example, this could be 9, and this could be something like square root of 27, right? Wait, 81, there we go. So what do you do here? Like, do you convert this thing? You convert this thing into double, right? And since this is double, this must be a double, right? And then this is double, this is a double. Actually, this would work, but not because, well, actually, like if you do this, you could argue that, oh, 81 here should be converted to double, such that x here is still a double, such that 9 here is a double, such that this actually works as a double. And that's just stupid. I mean, you could do that. It's a bad idea, because then if you reuse 9, for example, later, and you do 9 plus 3, and this is an integer, then what do you do? Like, do you convert this 9 into an integer? But it's already been converted as a double, so it's going to be inconsistent. So that's why as soon as you have one level of indirection, you just give up on all conversions, because it's too easy to mess up and to be inconsistent. And consistency is really important in programming. So we've seen type conversions and types. So doubles, floats, int, they're all types that represent numbers. So those are like numbers with decimal places. those are whole numbers with negatives, and there are others like uint, and then you can have arbitrary precision, uint 32, etc. Actually, I can probably see them here. Yeah, uint 8, 16, 32, 64. What else do we have? Int 8, int 16, yeah. So just different kinds of like different implementations of integer numbers. All right, now let's get to the second most intuitive thing you can write, and that's what we've seen at the beginning. Those are strings. Hello. So if I just type hello, nothing happens because the code just executes this 9 and then does nothing with it. But if we can pass it here, it's going to execute the square root and put it inside John, and then John will be printed out to our console here, and we get 3. But hello here, we just say hello, and the code just reads hello, and nothing happens. So since nothing happens, we have to do something with it, and one thing we can do is print it again. And now we can see hello in the console. So what is special about strings of character? It's a bit strange. Like you can't really do hello plus 3. Like what does that even mean? But yeah. But you can do that, right? Hello plus Sam, and you get hello Sam. So there is a lot of strange things you can do with strings. So here, this is called concatenation. You take one string and you take another string and you just stick them together. And for the sticking together part, you use a plus sign. Can you do minus? You can't do minus. So you can do plus, you can't do minus. Can you do times? All right, you cannot do times. Is there anything else you can do? Not, well, you can do, wait, oh, that's interesting. Oh, that's not gonna work. Strings of index, no. You can do that. And that removes the first letter. But no, like generally there's no mathematical operation that you can do in strings, which is a bit strange. Like it's a bit strange knowing that we have the plus sign. But we're going to see later why it makes sense to have plus and not other operations. So, and I'm gonna say like plus is a, and that's why. So I can print out strings. You notice that if I type dot, I have a whole bunch of text coming out here. And those are all operations that you can execute on a string. So for example, if I do is empty, it will tell me hello is not empty. Like it'll tell me false. And the reason it's telling me false is because we're looking through hello. We're checking if hello is empty. If it's empty, we say true. If it's not empty, we say false. Here we say false, and then we print the result. Since the result is false, we return false. All of that is very, it's a bit arbitrary, but it's also quite simple, I think. If you're not familiar with programming, it's a bit arbitrary. but that's how most of them work. So that's why it feels intuitive for a lot of programming people. So here's where the fun part begins. Oh, just last thing. You can say true and you can say false. Those are two statements, true and false. Here is the thing. How can you combine those things together? How can you combine, for example, I want to say, I want to have a value that represents a person. And for me, a person, it has an age, a name, and what could have? An activity, or like, does it have a job? Does this person have a job, right? And the last thing they could have is right, the length of their hair, but like not as a number, as a category. So there is bold, short, medium, long, and very long. And we won't say whatever number it is, but that's what we're gonna have. So bold, short, medium, long, very long. Those are all our categories. So you can't just have one value that does everything. This is a compound of different values. The value for age, which will be a number, the value for name, which will be a string of characters, the value for job, which will be a Boolean, and the value for length, which will be one of those 5 values. 1, 2, 3, 4, 5. Yeah. So first, let's go with age. So for this, I'm going to write a type alias. A type alias is just giving a name, another name to a type. So age will be an integer numbers. That means you can have negative ages, but that's okay. Name will be a string, right? Now, job is a bit harder. Like we want to define having a job as a value, but since there is only 2 choices, has job or has no job, we're gonna say is employed, and that's a Boolean value. And finally, length of hair, we're gonna use an enumeration, and this allows us to create multiple cases for multiple values that we artificially construct. So there is bold, short, medium, long, very long. Those are all our cases. And now I'm going to define a person as a aggregate of those 4 characteristics. And there's 2 ways of going about this. The first one is this. You say person is just age, name, is employed, and hair length. And the parenthesis here is it's called tuple syntax. And this drives me insane. I've never been in my entire school life been told what is a tuple until I became a programmer. And even then, as a programmer, it came to me very late. So here's the thing. Do you know what's a pair? Do you know what a pair is? Like a pair of things. It's just 2 things, right? Right? Do you know what's a triple? A triple is just 3 things. Do you know what's a quadruple? Quadruple is 4 things, like quadruplets, etc. Like quintuple is 5 things. Sextuple is 6 things, right? So you can see the pattern, except for two. Like it's blah upple. And so some people say those are n uples. Actually, is that true? Maybe it's only in French. Which mean n things. Or you just say those are tuples. So n things. So this is a quadruple, but Swift has tuple syntax, which means you can put parentheses and you can put elements here separate by commas, and that will make a tuple of the right amount of elements, where the right amount of elements is the amount of elements you've put in there. So this will be a quadruple. And if I put one more, it's going to be a quintuple, etc. I don't know if there's a limit. Some languages have limits like 32. You can't go higher than 32. So that's what a tuple is. You just put stuff in parentheses and just aggregates them. And the great thing about tuple is that they don't have to be the same types. For example, if you say I have a pair of socks, you have to have two socks, and you're talking about twice the same thing. Or like a pair of headphones, or I have a pair of birds at home. It means you have two birds. But in programming or in math, when you say a pair of things, it could be a pair of one thing and a completely different arbitrary thing. That's the key difference. So if I say int and string, that's a valid pair. Even though we're talking about different things, we're talking about two things, and that's what matters. So tuple is just putting stuff into parentheses and aggregating them and talking about all of them at the same time, saying, I have this batch, this box, it has all those things, and I don't care about what it is, I just care that there is 2, 3, 5, 10 of them, and the types are those ones. And so here we're saying person, it's a tuple, it has an age, it has a name, it has an employment status, and it has a hair length. That's it. Like, it's 4 things, and that's how we define it. And then we can say Jane. Jane is 50. Her name is Jane, and Jane is employed, and hair length is medium. I don't know. Oh. There we go. So you noticed here, I just had to quickly say to, so if I remove this, it's going to complain that expression type in string bool blah is ambiguous without more context. And it's because it cannot guess that medium comes from here. I guess if I do, wait, what? Yeah, if I do hair length dot medium, that will work. Yeah. Right. So if I tell it medium is hair length, that works. But also if I tell it that Jane is a person, it will look at person and be like, wait, what is a person? A person is this tuple of 4 things. The first one is integer. Is this an int? Yes. Second one is name. Is this a name? Yes. Third one is employed. Is this an employment status? Yes. And last one is hair length. Is this a hair length? Yes. And then it says, okay, you're right, good to go, because you said it was a person, it actually could be a person. But that's not very handy, because if you want to get the name of Jane, well, it's Jane, but if you want to get the hair length, you have to do this thing where you have to say, print me the employment status of Jane, and you can't just say employment status, you have to say, give me the third element of the tuple. Oh, and I got it wrong. See, that's a problem. I got it wrong. The third element is the hair length. The heard element is not the employment status. So here's the problem. Like 3 does not tell you anything about the nature of the value that you're interested in. It just tells you it's the third going from left to right in the tuple. And that's annoying. There is a way to go around in Swift using tuples, but I'm going to scratch that because it's dumb as shit. It's not fit for our purposes. And I'm going to use a struct person. And structs are almost the same, except when you bundle things together, you give them names. They have a bit more, like they have more properties, but this is the big one. So age is an int, name is a string, is employed is a Boolean, and hair is hair length. And now if I take Jane again, I have to construct this struct. That's why it's called struct. It's because it's a structure. And I say person, and then it gives me here all the constructors, all the things I need to give it for it to be correctly constructed. So age is 50, name is Jane, is employed is true, and hair is medium. All right, and now we do Jane.hair. And there we go, we got Jane.hair. What happens if I do just Jane? Can you print out Jane? Oh, look at this, look at this. If you just put Jane in there, it's going to look at this thing, and it's going to look at every single field in there and try to give it the value and show the value. And like, for example, this doesn't always work great. Like, if you see that, that's not what we want to show, right? I mean, it says the value that we have in hair is the value medium from the type hair length from the file Swift intro. And what we really want to show is medium. We don't care about where the value came from, right? So this brings us to, wait, what time is it? Wait, what the hell? Wait, what time is it? It's 9, right? It's not 10. Why does my iPad say, oh, I'm stupid. Okay, never mind, never mind. Oh my god, small heart attack. All good, all good. It's 9. All right, I should stop. But this brings us to the next topic. So we've seen enumerations, we've seen records, structures. The next thing we need to see are generics and protocols. Before we jump into this, there is one more thing I would like to mention, and that is employed here is a bool. That's usually bad practice, because if you just see the value true, you don't know where it came from. Like if I just have here, you have false, but you don't know what that means. It just means something somewhere is false, but is it bad? Is it good? Is it expected? So you have to go back in the code and find, oh, false is just nothing. We just said false. But here, if I do Jane.isEmployed, I get false and true, and I don't know what that means. So a good practice for this is to give names to those values. And for this, we're going to do the same employment status. Unemployed. We're going to do the same thing. We're going to give we're going to make an enumeration that has two values. Either we are unemployed or we are employed, right? And say is employed has an employment status. I'm going to say Jane is employed. I'm going to run that again. Oh, and now we know what's going on. We not just have true or false, we have a status employed. That means, like, we still don't know who it is, but we know that we're talking about a person and its employment status. All right, one more thing. Here I can say, if I'm employed, if the value that I have is employed, I can put the name of the job as a string in there. And so employed here, I'm going to say scientist. And when I print the thing, we have even more information. We know that whoever is employed is a scientist. It's not just unemployed. Or it's not just employed and then we don't know anything anymore. So by using enumeration, we can get a lot more information than just strings or booleans. We can combine those in order to get extra information when constructing their values. And so this is a case where it's really useful to know where the value came from or what it means, rather than just have true or false. All right, and as a sneak peek for next time, I'm going to do this. Custom string convertible var description switch self. Please fix it for me. I don't care about this. And this is return bold. This is return short hair. This means return medium hair. This is return long hair, and this returns very long hair. And if I print Jane now, boom, hair says medium hair, and we can even remove the hair actually, because we're always talking about hair in this case. Oops. There we go, hair medium. Doesn't go through value medium from type hair length from file switch, what was it? Swift intro. Oh, it does it for employment status, it's fine. But what we did here is we gave, we equipped the type hair length with the protocol custom string convertible. And equipping any type with this protocol allows every value to be printed out in the console as the value that it returns here. So if we get bold, we return bold. If we get short, we return short. If we have long, we return long as a string instead of the whole path. And we can do the same thing. Here we can say custom string convertible, and I say the description of this is, if we're unemployed, we say, oh no, go find a job. And if we're employed, say, we just say, actually, has job, and then we concatenate the name of the job here. Oh. There we go. and then it says is employed says has job scientist. And if we put unemployed here, it says, oh no, go find a job. That's it for today. I'm not gonna program Idris or anything because I'm dead tired. So I'm going to upload this to YouTube and I'm just gonna go sleep. All right. See you on Wednesday. I'll keep doing the same thing. I'll go into protocol, generics, all that good stuff. Bye.